So in the last video we introduced the notion of the Cartesian coordinate systems, and I also mentioned the position vectors. So now it is our turn to expand our knowledge of vectors and learn about the addition and subtraction of vectors. Now vectors are quantities that have both magnitudes and directions. Therefore, when you add two vectors, you need to make sure that you are taking into account both of these factors, and you are producing a vector that is representative of the magnitude as well as the direction of the vectors that you are trying to add. Okay, so there are specific rules for vector addition. First, we are going to learn how to add two vectors geometrically, and then we will try to derive some results. So let us say that this is vector A and this is vector B. So we want to add vector A to vector B. So the procedure is you take B, and for now you can think that there is a general rule that you can take any vector and displace it parallel to itself. Okay, now this rule is not always valid, but for now, for introductory physics classes and mathematics courses, you can take any vector and shift it parallelly, most importantly parallelly, anywhere on your plane or in your space. Okay, so we will shift this vector in such a way so as to join the head of one vector, that is the arrowhead of one vector, to the tail of the other vector. Okay, so just now you saw that the head of A was joined with the tail of B, and then we are going to join the initial point of A and the arrowhead of B, and then this will give us the resultant vector, let's say R, and this R vector is what is A plus B. Now this is the procedure. I have not yet justified to you why this is true, but this is the general procedure. You are given two vectors, you have to keep one of them as it is, take the other vector, move it to the first vector in such a way, move it near the first vector in such a way that the tail of the second vector coincides with the head of the first vector, and then you have to join the initial and final points to produce your resultant vector. So another quick example, let's say this is vector P and this is vector Q. Okay, so now I'm going to move P. So I take P and I move it in such a way so that the tail of P is joined with the head of Q, and then I'm going to join the initial point of Q to the final point of P, and this is going to be my resultant vector P plus Q. Now this method, where we join one vector by the head and the other vector by the tail, and draw a vector from the initial point of the one to the final point of another, this is known as the triangle law of vector addition, and I am sure that you can see why it is named so. But there is another law of vector addition known as the parallelogram law of vector addition. In this case, what we do is we take the vector A. I'm going to try to take the same vectors, and then I take the vector B. But this time, instead of joining head to tail, we are going to join tail to tail. That is, we are going to take the vector B, displace it parallel to itself, that is by keeping its direction constant, and I'm going to join the tail of A to the tail of B. Now, what I'm going to do is, I'm going to replicate the vector A once again, and now I'm going to draw it from head of vector B. I'm going to replicate the vector A again. Okay, so this is fairly a drawing of vector A, and then what I'm going to do is I'm going to complete the parallelogram, and this is again vector B. This particular length is the magnitude of vector B, so the parallelogram has the property that opposite sides are equal, so this length will also be equal to this length, and since I have deliberately copied this length, then by elementary geometry this vector should also represent this vector B over here. Okay, so this is the completion of the parallelogram. Now what we do is we join the tail to tail to head to head. This is our resultant. This is A plus B. Okay, and this one is known as the parallelogram law, and I'm sure again that you have understood why it is known as the parallelogram law. But something that I need to mention over here is that at the first go this might not seem to be very easy. Okay, This is not very easy because you are not very familiar with completing parallelograms and completing triangles. So I suggest that you practice more and more examples. We are also going to bring up a series where we practice numericals and examples, where we practice all these things. But for now, I want to tell you that this is the procedure. I have not yet justified how we are how this relates, that why is the resultant actually drawn like this, and why is it actually equal to a plus b. And same for this case, I have not yet justified this, but once I justify the triangle law, you will automatically be able to find the reason for the parallelogram law. Okay, so don't worry about that. We are going to do it in another video, because for that you might have to understand the notion of components of vectors and the notion of dot products and so on. Okay, so I'm going to give you a formula over here. I'm also going to prove the formula later on in the course when I have finished with dot products and components of the vector. Now the resultant of a and b is not going to have a magnitude of a plus b. Now this is your first thought, but the resultant of the resultant r, let us say that this is a plus b. This is intuition, but I'm sorry, but this is wrong intuition. Maybe you can say it like this, but no, this is the wrong intuition, because the reason is simple. This is a triangle, and the sum of two sides of a triangle must be greater than the third side. It cannot be equal to the third side if it is to become a triangle in the true sense. Okay, but the resultant r is actually given, the magnitude of the resultant r is actually given by this formula: a squared, that is the magnitude of a squared, plus the magnitude of b squared, plus 2 times the magnitude of a times the magnitude of b into cosine of theta. Okay, the cosine of theta is the angle between the two vectors a and b. So you might think that the cosine of theta is this angle, and that will be wrong. Okay, so cosine of theta is not this angle. By convention, angle between two vectors, I might as well as make a note over here, angle between two vectors. By convention, angle between two vectors is always taken as the angle between the intersection points. I mean the angle when the vectors are joined from tail to tail. This is the angle between the vectors, two vectors theta, a and b. So in this context, this cannot be the angle between the two vectors. You have got to extend a. If not extend the whole of a, then at least you have to draw a dotted line along a, and then this angle will represent the angle between a and b. In this figure it is very easy. Because in this particular figure, a and b are already joined tail to tail, so this whole thing is the angle. Okay, so if you allow me to delete this for once, you see, now you can see that a and b are joined tail to tail. Therefore the angle between them, I mean this particular angle, is the angle between the vectors. Okay, so in this case it is easy to see. So theta is this very angle. Okay, but in this case theta is not this angle. Okay, so you might make mistakes like this in the future videos, but please don't do so, because I have warned you now. And again, let me tell you, if this is not making, you are not quite comfortable with this right now, then don't worry, because we do not expect you to be comfortable with this at this stage, because this is something that is completely new to you and you have to get used to it basically. Okay, so again, I have not justified, I have not proven this formula to you. That is something that I'm going to do in an upcoming video. And again, this is by convention. Tail to tail joining is necessary. So by convention, tail to tail joining is necessary. Now you might have asked me, what is the problem if we take the angle of the vector to be this? No, you cannot, because we need to standardize things in science. Therefore we have standardized this by convention, that we have to join two vectors tail to tail in order to take the angle between the two vectors. Okay, so I think you are now familiar, if not comfortable, with the notion of addition of two vectors, and the addition of two vectors follow two laws, or you can add that two vectors in two ways. You can add them by using the triangle law, or you can add them by using the parallelogram law. The resultant vector will have a magnitude that will be given by this expression, and the direction of the resultant is obtained either by using the parallelogram law or by using the triangle law. And the proofs of this thing, or the explanation that why these things hold and why the things and the resultants are drawn the way they are drawn, they are coming up in another video. Okay, so in the next video we are going to explore the notion of subtraction of vectors. However, that is not very different from addition of vectors, as you will find out.